We are now going to investigate quadratics a little bit more, and we're going to take a look at some formulas you might find very useful. Okay, first of all, vertex form of a quadratic is when it's in vertex form. The vertex is very easy to see. We've got a times the quantity x minus h, that quantity squared, plus k. Vertex form, you can see the vertex. The vertex is h comma k. And why is it positive h? Because minus h means go to the right. So the vertex is h comma k. And the axis of symmetry is x equals, it's always that x value, h. Okay, now that's nothing new. Today we're going to take a look at some formulas. Instead of completing the square, we are going to use h and k formulas. Okay, so h is negative b over 2a, and the k formula is c minus b squared over 4a. Now k is a little more complicated. It's a little bit longer. They both have a minus sign. They both have b's in the numerator, except h is just a b and k is b squared. They both have a number a. Now h is a little smaller. He gets 2a. This one gets 4a. I want you to take a look at those for the next 2 minutes and just study them and memorize them. Okay, you got them? All right, we're going to push the paper up, and I don't want you to look at the formulas. We're just going to look at this problem here, and we're going to try to use those h and k formulas to find the vertex. Okay, to find the vertex, we're going to use the formula. So h equals, without looking, look up and tell you around the h formula. Negative b over 2a. All right, how about the k formula? K equals c minus, okay, this fraction's a little bit bigger, b squared over 4a. Okay, good job. Now we're going to take a look at this quadratic, and we're going to use these formulas. So whenever you have a quadratic equation, the a number is in front of x squared. So this is standard form. The b value is 8, and the c value is 5, a, b, c, just like we're going to do the quadratic formula. Okay, so we're going to find h. H equals negative b. So not a positive 8, but a negative 8. And then we're going to divide by 2a. And that's a 2, so it's 2 times 2. Okay, now in this class, I highly recommend canceling. This entire chapter and this test is going to be without a calculator. So if you like to multiply the numbers together, make big numbers, then you have to calculate with big numbers. However you do this, you're going to get negative 2. All right, let's take a look at k. Give me a c. 5. Okay, minus b squared. That's 8 squared. Write 8 times 8, please. Okay, don't ever multiply those together because you're going to immediately divide by two numbers here, 4 times 2. And so again, instead of making huge numbers, I want you to start using the art of canceling. So 4 can cancel with 8 to make a 2. And then this 2 can cancel with that 8 or that 2, doesn't matter. You can cancel 2 and 2. And so when you cancel, you have 1s. So this has been reduced. Where's my k? I got to put a k letter here. K is 5 minus 8 times 1 to 8. So k is negative 3. So what is the vertex for this parabola? Negative 2, comma, negative 3. The h and k formulas. Okay? It's the same result as when you would complete the square. The axis of symmetry, that's very easy. It's always going to be a vux. It's going to be x equals, grab that h number there, negative 2. And writing this in vertex form, okay, it's going to be f of x. Okay. Is there an a value out in front? If I take a look at this, if I was to complete the square, I would factor a 2 out. There definitely has to be a 2. Well, there is a 2 for the a value. See that number right there? Now the rest of it comes from your vertex. I know it's going to be x something something squared, h and k. So since this is minus 2, I am going to put plus 2. Wait, is that right? Plus 2 goes to the left? Yes, that works. So whatever your h is, you're going to put the opposite. Remember, the vertex form is x minus h. So if I minus a minus 2, it's a plus 2. But then it's just plus k, so it's just going to be minus 3. Okay, we did this exact same problem if you look back a couple of pages. We did this exact same problem here by completing the square and got the same answer. So completing the square and using h and k formulas give you the same result. So tonight's homework, I want you to practice all h and k formulas to get good at that. All right, let's graph using h and k. All right, here we go. First, we're going to find an h. Give me a negative b over 2a. All right, give me a negative b. Not a positive 6, but a negative 6 divided by 2 times a. Well, that's negative 6 divided by negative 6, so that's going to be a 1. So the vertex is 1 comma something. Now it's time for k. K equals, what's that formula? C minus b squared over 4a. The more you write the formula, that's kind of like memorizing it. So give me a c. 1 minus b squared. So let's write 6 times 6 divided by 4a. That's a negative 3. And now we have to look for things that cancel. I can cancel a 4 and a 6 each by 2. So that 4 becomes a 2 and the 6 becomes a 3. Oh, we can cancel a negative and a negative. We could cancel this 3 with this 3. So now I've got 1 plus 6 divided by 2. So k equals 1 plus 6 divided by 2 is 3. So the k value is a 4. The vertex is 1 comma 4. This graph opens which way? Looking at the original equation will help you with that. This graph opens down. Okay, whenever you're talking about a parabola, the domain is all reals. Maybe I'll look at my graph for the range. Writing the equation in vertex form, that's something we could do. F of x equals, is there an a value out in front? The a value, yes, is negative 3. Now it's time to write the vertex in here. It's going to be x. Since that's a positive one, I have to write minus 1. It's x minus h. And then plus a k, so plus 4. And just double check. 1 to the right and 4 up. Yes, perfect. Okay, let's go get this thing graphed. So the vertex is 1 comma 4 right here, and there's a vertical stretch by 3. So over 1 down 3. Over 1 down 3 times 3 is 9. Over 1 down 9. Okay, so here's the parabola, not 1, 3, 5, but 3, 9, 15. Okay, so what is the range? Looking at this graph, it goes from as low as negative infinity all the way up to as high as 4. And it touches 4, so brackets. Is it always going to go all the way up to the vertex, or if it's opening up, start the vertex? Yes. So that k number right there is going to come in handy for range. And where is this graph increasing? This graph is going up, 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 hitting the maximum, and then it's decreasing down, down, down. So it's increasing from negative infinity all the way up to 1. I use a bracket. And then it decreases from brackets 1 to infinity. Okay, and remember, for both of these, use x values like domain. You're stating the domain, but only a part of the domain. Okay, let's use this quadratic equation here to find the vertex. And we're going to use h and k formulas again. So h equals negative b over 2a. And we've got negative 1 over 2a. 2 times 2 is 4. So the h value is negative 1/4. It can be a fraction. Yep. K is c minus b squared over 4a. The c value is 1. The b number is 1, so 1 squared is just 1, over 4a, 4 times 2. So we've got 1 minus 1/8. When you are adding or subtracting fractions, you need to make a common denominator. So how should I write this 1? And the answer is 8 over 8. 8 divided by 8 is 1. So what's 8 over 8 minus 1 over 8? And the answer is 7 over 8. Okay, so it's okay to get fractions for your vertex. The vertex is negative 1/4, comma 7/8. Axis of symmetry is x equals that x number right there, negative 1/4. This graph opens, I need to look at the original equation. Since it's positive, it opens up. Writing him in vertex form, don't forget f of x equals, give me an a. The a value is the same as there, 2. And then you got to put the vertex in, x minus h. Since it's negative, it's going to be plus 1/4. It seems silly, but don't forget the squared, because these are parabolas, plus 7/8. Okay? So you have to get really good at memorizing and using the h and k formulas. Okay, the discriminant formula. The discriminant. So this is something that you learned when you were in Algebra 1. And it's b squared minus 4ac. And the discriminant tells us how many solutions. Or we could say x-intercepts the graph has. So it's from the quadratic formula. Remember the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So where is the discriminant located? It's under the radical in the quadratic formula. So I'm not doing the entire quadratic formula. That would be if I want to find the solutions. I just kind of want to know how many there would be if I finish the problem all the way. So if the discriminant, if the stuff under the radical is positive, then you could keep calculating, you could keep going. There would be 2 real solutions. 2 real solutions. And so you'd have a parabola like this, opening up or down, either way. And where are the solutions? There they are. 1, 2. Okay, and those are called 2 solutions. They could be called x-intercepts. They could also be called a couple more things. Who knows what they are? Starts with R. They could be called the roots, or they could be called the zeros. Okay, so there's 2 of them. If you get a positive discriminant, that means you could keep going and calculate the 2 x-intercepts. All right, what if under the radical, what if the discriminant is negative? Can you have a negative in the radical? No, so then there would be no solution. And so what does the parabola look like? Well, it's either way up here opening up, not touching the x-axis, or maybe it's opening down, but not touching the x-axis. So it's either there or there, but it would not be touching the x-axis. And finally, what if the discriminant is 0? What's the square root of 0? The square root of 0 is 1. Then you only get, the square root of 0 is 0, and you only get 1 solution, because plus minus 0 is actually just 1 answer. What would the graph look like? It would touch the x-axis 1 time. It would be brushing the x-axis in 1 point. So both of your solutions are exactly the same point. It could be opening down too. Okay, use this quadratic function here. Okay, how many x-intercepts does he have? How many? Well, let's use the discriminant. When it says how many, they want you to show the discriminant work. Use the discriminant. And the discriminant is b squared minus 4ac. So let's look at this problem here. B squared, that would be negative 4 with parentheses squared. Minus 4, give me an a. The a is 1, and the c is negative 5. So 4 times 4 is 16. I've got minus, that's going to be plus. So I've got plus 20. And so the answer is positive. Positive, who cares? Okay? Since it's positive, there are going to be 2x intercepts. 2x intercepts. Okay. If there are some, find them. Oh, that made it find them? Okay, yes, there are some. How are you going to find x intercepts? Okay, you're going to let y equal 0. So 0 equals x squared minus 4x minus 5. So this seems like they want me to do a factoring problem. Everything's over to one side. X is positive. X times x is x squared. The only way to make a 5 is if I do 5 times 1. Now I have to make a negative 5, so one of them is going to get negative. My middles here need to have more negatives than positives, so if I put the negative and the positive, does that work? X squared? Yes. Outers 1x, inners minus 5x. That's looking good. Okay, so what are the x-intercepts? 5, comma 0, of course. We want to write it as a point. And negative 1, comma 0. I found the x-intercepts. Okay. Determine whether the quadratic function has a maximum or a minimum. Okay, this is a really, really easy question. A maximum or a minimum. Okay. Opens up or down? That's the question here. Does this parabola open up or down? Up, you say? All right, here's a nice picture of it. Does he have a maximum or a minimum? He has a minimum. He has a minimum. Minimum. Okay? So that's just a question of which way does it open. Now find it. How do you find it? That minimum is a vertex. I will use the h and k formulas. H equals negative b. 4 over 2a. 4 divided by 2 is 2. Let's find the k value. C is negative 5 minus b squared. That's negative 4 times negative 4. Those negatives will cancel. Divided by 4a. So those negatives canceled. One of each of these 4's will cancel to make 1's. So now we're down to negative 5 minus 4. So k is negative 9. So what's the vertex? 2, comma, negative 9. Okay, if it asks whether it has a maximum or minimum, you just have to think whether the parabola is opening up or down. Up or down. Okay, the last thing that we're going to do here is kind of put it all together, because we know a lot of different things about parabolas. Okay, how do you find the vertex? Okay, first of all, where is the vertex? The vertex is right there. The point that's either the highest or the lowest on the parabola. Okay, that's the h, comma, k. So how do you find a vertex? Well, there's two things you could do. Number one, you can complete the square. If you want to complete the square, that's one option. Or option two, you can use the h and k formulas that we learned from today's lesson. Either way will get the job done. But that's if you want to find the vertex. Okay. How do you find y equals value? So what if I said, where does this parabola equal 7? Well, I could tell that it's clearly touching 7 in two places. So what you do is you say 7, or whatever your value is, equals equation. You put 7 in for the y value. Then what you do is you say 0 equals equation, and this is a quadratic equation. So then you could either factor, or you could use the quadratic formula. okay, to solve. That's how you solve a quadratic equation. What if it wants the zeros or the roots or the x-intercepts? See, all those things are located right here. Here they are. Okay, and whenever you touch the x-axis, you have a 0 for the y value. You let y equal 0. So you're kind of picking up right here at this step. So you already have 0 equals equation. And then what do? Well, you either factor or you use the quadratic formula, okay, to solve. So we're kind of at the same point there. Okay? So some people ask me, well, how do I know what I'm doing? Well, it depends on what you want to find. And a visual really helps with that. So for example, here's a quadratic equation. Let's find the vertex by completing the square. Okay, so this is review from yesterday. So the first thing I'm going to do is take a look at the x's and get x squared alone. So I'm going to take the negative away. X squared minus 8x. What about that minus 12? Oh, that just gets shoved way down there. Okay, and now it's time to half and square. Half of negative 8 is negative 4, but squared would be plus 16. So how much did I just add in disguise? That's negative 16. So let's compensate with a plus 16. So f of x equals negative. I'm going to go ahead and factor that. It's always x. That sign right there tells me minus, and that's going to be a 4 plus 4. So the vertex is 4, comma 4. Okay, then it says find the vertex with h and k formulas. I'm pretty sure I know the answer, but they want us to try another way just for practice. So the h formula is negative b. That would be a negative 8 over 2a. That's a negative 2. Oh, look at that. I'm getting a 4. Good. I like that the answers match. And k is c, which is negative 12, minus b squared. I'm going to write 8 times 8. Don't make big numbers. We're going to cancel in just a second. Over 4a, which is a negative 1. The first thing that could cancel are these negatives. 8 divided by 4 is a 2. So now we have negative 12 plus 8 times 2 is 16. So k is a 4. K is a 4, just like we got up there. Okay, everything's working out. So when you see the work like this, some people say, well, isn't completing the square actually a little easier? Sometimes a little easier. Some people are formula people, though. Tonight on the homework, we're going to do h and k practice. But on the test, if it doesn't say, do what you like. When is f of x a 3? Okay, f of x is a 3. So they want me to take this f of x right here, and they want me to plug a 3 into that. 3 equals negative x squared plus 8x minus 12. So this is kind of like option 2 here. They want me to, when is the parabola equal to a 3? Okay, so I'm going to make everything move to the left side. I want to make a positive x squared. X squared minus 8x. Switch sides, switch signs. So that's going to be adding 12. 12 plus 3 is 15 equals 0. Okay, factoring here looks pretty easy because it's just x squared, so that's x and x. A 15, see, it's probably 5 and 3. Yeah, 5 and 3 to make it 8, right? 5 and a 3. To make a positive 15, they need to be the same, and I think they both need to be negatives. Okay, so x is equal to a 5, and x is equal to a 3. At those places, the y value is 3. Okay, find the zeros. Find the zeros. So that means let y equal 0. 0 equals negative x squared plus 8x minus 12. I'm not a fan of factoring when the problem is like this. So let me ask you guys something. Can I just change all these signs? Can I just change this one to positive, negative, positive? The answer is yes. Wait, what is she doing? Well, you can multiply the entire right side by negative and the left side by negative. Or you could think of it as, what if I move them all to the other side? If you move them all to the other side, that would change all their signs. So what we have here is positive x squared minus 8x plus 12. But you can change legally because you kind of like multiply the left by negative. All right, let's go ahead and factor this into x's. How do you make a 12? 3 and 4. Don't make an 8. 6 and 2 would make an 8 if I did minus 6 minus 2. So let's state the zeros. 6 comma 0 and 2 comma 0. Okay, are you ready to maybe look at the graph and put this all together? The vertex is 4 comma 4. 2, 3, 4. 1, 2, 3, 4. 4 comma 4. Let's see. The x-intercepts are 0, 6 comma 0. 1, 2, 3, 4, 5, 6. And 2 comma 0. This parabola is opening down, over 1, down 1, over 1, down 3, over 1, down 5, over 1, down 7. 1, 2, 3, 4, 5, 6, 7. Oh, there we go. Okay, so it's a regular growth parabola, no stretching. Okay, there's the parabola. Now, everything that we found when we did our algebra up there should be on this picture. Okay, is the vertex at 4 comma 4? Yep, vertex is 4 comma 4. When does f of x equal a 3? 1, 2, 3. So here's the value of 3. Okay, I'm finding it at 3 comma 3, and it's touching at 5. And those are the answers I got mathematically. At 3 and 5, the graph touches 3. How about the zeros? How about the x-intercepts? Do I have one at 2? Absolutely. And I should have one at 6. Perfect. Okay. Standard form is the way that it was given to us. Standard form is negative. We've got the ax squared, we've got the bx, and we've got the c. Vertex form, I need to pull the negative out in front, and then the vertex is x minus 4 quantity squared plus a 4. That's vertex form. That's the one that helps us graph. How about factored form? F of x equals, take a look at the original equation. The negative would be pulled out, and then we actually had it factored right there, x minus 6 and x minus 2. And those values right there should be the x-intercepts. Okay, have a great day.